everyone. Welcome to today's Science Talk. I'm delighted to welcome you. My name is Dr. Miriam Axel, and I'm thrilled to be your host today. For those of you joining us for the first time, welcome. Our weekly series, the Science Talks, highlights the exciting research of UNU-INWEH's researchers. I'm pleased to share that all of our previous Science Talks are available on our YouTube channel and on our website live on demand. And today's talk, like all others, will be recorded and made available after the session. Also, please note that we will conclude with an interactive question and answer session, so please do use the chat function to put your questions and we will share them with our speaker. The topic of today's talk is Trends, Patterns, and Social Vulnerability Landscape of Exposure to Wildfires in the United States. Dr. Mojtaba Sadegh, or Moji Sadegh, is the lead for climate and wildfire analytics at UNU-INWEH and an associate professor in civil engineering at Boise State University. His research focuses on climate extremes, natural hazards, and the intersection of engineering and climate science. He integrates data-driven methods and modeling approaches to assess disaster risk, human exposure, and resilient strategies in wildfire-prone and climate-sensitive regions. At UNU-INWEH, Dr. Sadegh is leading a new research initiative on climate and wildfire analytics with the goal of developing scientific, educational, and policy materials to facilitate mitigating and adapting to climate change and wildfires. His efforts are focused on bridging the science policy gap to mitigate devastating wildfire impacts both globally and regionally, and exchange knowledge and information with the scientific community and the public through diverse outlets. Without further ado, I'm pleased to pass it over to you, Dr. Sadegh.
Thank you so much, Miriam. Let me share screen and start this presentation. Good morning, everyone who are in the Americas, and good time to the people joining from across the world. Thanks for the opportunity, and I appreciate your time being present today. So today I will focus on the wildfire impacts, human wildfire impacts in the United States, but try to also allude to some of the global impacts to the extent possible. So there is an increasing number of wildfire disasters that have happened in recent years in the United States and in certain regions globally. Just a few of them are shown here on the screen. Just get my pointer here. So on the left, you see the Maui fires in 2023 that killed more than 100 people and destroyed thousands of structures. We had the Camp Fire, the 2018 Camp Fire in Northern California, that also was very devastating, killed 85 people, and several dozen thousands of structures were destroyed by the fire. The Marshall Fire in Colorado in 2021 was quite fascinating in a sense. This was a real shock because it happened in a time that we really don't expect the fire to happen, right? So this is December 31st in Boulder, Colorado, and the week after we had a snowstorm coming in town. So the fires are happening and are happening in certain times that are not necessarily expected. And recent Los Angeles fires, you all probably have heard of the fires in the news, killed more than 27 people, destroyed 16,000 structures, and this was also in December. Now, when we talk about wildfires, most of the time we talk about increasing wildfire activity. We talk about increasing burned area by wildfires, increasing forest fire burned area or wildland burned area. And in the United States, especially in the Western United States, depending on how far back you go, we have threefold, fourfold, tenfold increase in the burned area in recent years compared to 3 decades ago. We have 3-4-fold increase. Compared to 5 decades ago, we have about 5-6-fold. And then if you go back to the to the 40s and 50s, we have up to 10-fold increase. If we go further back, the increase is not going to be as much because we had a fire deficit in certain decades, which I'm not going to get into in this talk. But what I'm saying is, when it comes to wildfire activity, we are always talking about burned area. And burned area is increasing due to several reasons. Across the world, the reasons are a little different. And let me put it out there, the global burned area is not increasing. It's regional burned area that's increasing. That occurs in the Western United States, that occurs in the Mediterranean, in certain boreal forest regions. And usually the burned area is associated with warming and climate change, but it's also associated with human activities. Now, one study that I'm presenting here shows that the number of standard deviations departure from average in fuel aridity, which is basically how dry is the fuel, how dry is the forest that catches on fire, shows the burned area. So if the fuel aridity increases, the burned area starts to increase exponentially. And that's what we see in the Western U.S., that's what we see in the boreal forests of Canada and elsewhere. But what I want to argue with you today is that burned area is not a good metric if we are interested in human impacts of wildfires. Let me give you two example fires. One is the Martin fire in 2018 in Nevada. Right here in northern Nevada, it burned more than 400,000 acres, multiplied by 0.4 to get hectares. Casualty was 0. Losses were 6 ranches, and how much of those ranches were lost is not really known. But the losses is very minimal compared to the 2023 Lahaina fire in Maui that destroyed more than 2,000. It burned only about more than 2,000 acres. But the casualty was more than 100 people. So compare the 2,000 acres in Lahaina fire versus 400,000 acres in the Martin fire. And the casualty, the difference is 0 to more than 100. So the difference is huge. It's not necessarily the burned area that is causing human impact. It's the type of fires. It's the disastrous fires that are causing human impacts. And the loss in the Lahaina fire was more than 2,200 structures. Now, you can explore the fires in the United States using this portal, fpafod.boisestate.edu. You can select a certain state, you can select a certain year. It shows all the fires, the sizes, the cause, some attributes associated with that fire. Just a shameless self-promotion right there. But explore it. It's quite fascinating how many fires we have in this data set. More than 2.3 million fires are included. Anyway, back to the human impacts of wildfires. So if the burn area is not the metric to go, let's focus on population exposure to fire. So this is where human settlement and fires coincide. So in this study, we took the fire parameters, we took the population maps, we overlaid them on top of one another to estimate what is the number of people that resided within fire boundaries. And we call this primary population exposure to fire. We are only focusing on large fires. Large fires in the Western United States mean those that are 1,000 acres or more. Multiply that by 0.4, so 400 hectares or more. And in the Eastern United States, that's 500 acres or more. And we have the population maps at a 100-meter grid from 2000 to 2019. So the study is from 2000 to 2019, and we have done the analysis at the scale of each state in the contiguous United States. So we have aggregated data to the state level annually, and then we aggregated to the Western states, which are the 11 states in the west of contiguous U.S., and Eastern states that are the rest of the contiguous U.S. Primary population exposure in contiguous U.S. from 2000 to 2019 has been nearly 600,000 people. So just short of 600,000 people in 2 decades. In 2 decades, were directly exposed to fire. So these are people that had residence within the fire boundary. Secondary exposure. Now, we have the boundaries of fire. If we consider a 3-mile, 5-kilometer buffer around the fire, we call that secondary exposure. And the secondary exposure to fire has been nearly 21 million people. So that becomes really, really huge when we look into the secondary exposure. And that's important because some of these fast-growing fires, like the campfire that I mentioned before, it traveled 4 miles in about a few hours, right? So people that are close to fires, depending on how the wind is, depending on the fuel continuity, depending on the fuel dryness, can be in real danger of the harm of these fast-growing fires. So 21 million people were within that 3-mile zone that fires can traverse in just a few hours. Now, if we look at the trends, and I want you to take this with a grain of salt, the trends is really tricky when it comes to fire exposures and when it comes to 20 years of data, and considering the interannual variability that we have in the fire activity. But with that in mind, the population, the primary population exposure to fires, those that live within the boundaries of fire, increased at the rate of 1,200 people per year in the past 2 decades. That amounts to 125% growth in contiguous U.S. in 2 decades. That's more than twice the number of exposed people. So the number of exposed people increased more than twofold in 2 decades across the contiguous U.S. In the West, the trend was rather similar to CONUS. The trend was 1,240 people per year, but the rate of growth was a lot higher, 185% growth. That's nearly threefold increase in the number of people exposed. In the East, the exposures is rather decreasing marginally. None of these trends reach a statistical significance because of the interannual variability that we have and the short period of data that we have analyzed. But I want to get back to, remember, we talked about the fire in Nevada being so large, the fire in Hawaii being so small, and the impacts being so different. Let's have a look at 2 specific years here. 2003 in the Western U.S. 2003 was a small fire year. So the burned area was somewhere between 10,000 and 15,000 square kilometers. But the number of people exposed to fire were more than 80,000 people. Primary exposure, 80,000 people. And then we have another year, 2012, that's basically the largest burned area in our record across the Western U.S., but the exposures are not really that high. So basically what I'm again saying is that the burned area is not a good metric of human impacts. Now, across the contiguous U.S., 19 states observed increasing annual population exposure to wildfires, and the other states either didn't observe any change or observe decreasing trends. I want to get back to that idea that I posed earlier, that we are only looking into 20 years, and there is a huge interannual variability. For example, if we look at New Mexico, we see that the state is observing a decreasing trend in population exposure. But then again, our timeline is from 2000 to 2019. A huge fire happened in New Mexico with impacts with unprecedented impacts on the population in year 2022. So if you include that, then the trend would be increasing. So take that take that into mind. Now, across all the states within the period of our study, California observed the largest rate of increasing exposure. So 1,165 people per year was the trend in increasing exposure to wildfires. That is more than threefold increase. The only trend that was statistically significant was California in our study. So California almost accounts for the increase in entire contiguous U.S. In fact, primary exposure to wildfires in California accounted for 72% of all exposures across contiguous U.S. California accounted for 15% of the fire area. So it's not necessarily the fire area that's causing such a huge fraction of exposures. And also California accounts for about 12% of the population of contiguous U.S. that live within wildland-urban interface. I will come back to the wildland-urban interface, but that's basically where the wildland areas and urban areas intermingle. So that's where majority of the impact on human population from wildfires happen. Anyway, what I'm trying to say here is that the impact on California was disproportionate, and this was not driven neither by fire area nor by the population residing in the wildland-urban interface compared to the rest of the United States. This is basically the combination of the climatic changes that are more harsh in California, as well as the human development patterns that basically put people in harm's way in almost all valleys, all resided valleys of California, all the valleys that have human settlements. Now, I want to get back to these are driven by extreme events. These are individual events that are driving human impacts. For example, 2003 was a big year. Actually, it was the second largest human exposure to wildfires in our study period. And we had more than 82,000 people being exposed to wildfires. And this was mainly due to cedar fire in Southern California, in San Diego County, and a few other fires in the same year, in the same vicinity. Cedar fire caused more than 15 fatalities and destroyed 2,800, more than 2,800 structures. And if we look at the conditions of the 2003 fire, cedar fire, we see that it was extremely dry fuels, high winds, extreme erratic fire behavior. Keep that in mind. Let's go back to year 2018. 2018 had more than 100,000 people exposed, and we had the campfire that I displayed a figure or picture of in my first few slides. The campfire killed more than 85 people, destroyed nearly 19,000 structures, and this was also fueled by a sea of tinder created by drought. It was propelled by powerful gusts, and the flames grew rapidly and traveled rapidly. Basically, what it comes down to, these are individual events that are associated with dry, hot, windy conditions. And what we see across the United States, especially in California, and in many regions across the world, we see that dry, hot, at least the dry and hot, is increasing in many regions globally. And the dry, hot, windy is increasing in California and in several other regions in the United States. In coastal Southern California, where we observed the recent Los Angeles fires, if we look at the number of critical fire weather days, so these are days in which the burning index, which is the fire danger index, it captures the dry, hot, windy conditions. So the burning index for each, so we calculated the burning index daily for a long period from 1979 to 2024 or so. We estimated what's 97th percentile. So that's basically beyond the 97th percentile. We have really high extreme burning index. And then we counted the number of days that are above that threshold in each year. What we see here, let's focus on the gray trend line here, is that the number of critical fire weather days in the 1990s are about a few days, maybe 3 or so days. And now there are more than 30 days, 40 days in recent years in coastal Southern California. So basically the conditions that are conducive to that erratic fire behavior has increased by more than tenfold in Southern California. And keep that in mind, what we see is the conditions conducive to that erratic behavior is increasing, but the number of fires is not increasing. So when you see in the news that we have more and more fires, it's not more and more fires, it's more and more destructive fires, because fewer events are happening now, but fewer events are happening at the times that are conducive to disastrous impacts. And that is causing all the human impacts that we see and all the news that we hear about. Now, so far, I've discussed that population exposure to fires is increasing. I have already discussed that the burned area is increasing, at least in the Western United States. So what is causing the trend in increasing human impacts? Is it so we have more burned area? Is it just that? So we have more burned area, more people being exposed? That's one scenario. But we also have another scenario. We see a rapid growth of wildland-urban interface in the United States. Is it people that are moving into areas that are then impacted by fire, or is it fire encroaching upon human settlements that were there historically? So we wanted to disentangle these two drivers. But let me talk about wildland-urban interface very quickly. Wildland-urban interface is where the wildland, which we can have the wildfires in, are intermingle. So the wildland intermingle with urban areas, with human settlement. So we have the wildlands, we start to develop, and then we have the rural areas. And then as we develop further, we start to have suburban areas, and then we start to have the interface. So that's where that's where we have the wildland, and then we have the houses built, and then we have the interface between the two. And then we have the intermix, which is basically we have the wildland and we have sporadic houses that appear within the wildland. And then we have more. And as the urban areas expand, we have we have occluded, we have umber zone, and we have other areas. In any case, what we have seen is the wildland urban interface areas are increasing, and we have seen that the burned area is also increasing in the Western U.S. So the first step that we took here was that to normalize the population exposure to wildland fires by wildland fire areas. So exposure divided by burned areas. And then what is the trend in the normalized exposure across CONUS? In 2 decades, an additional 220 people per 1,000 square kilometer of burned area were exposed to fire. So the fire in 2019, 1,000 square kilometer fire in 2019 is exposing an additional 220 people compared to that in year 2000. In the West, this was even more. More than 700 people were exposed per 1,000 square kilometer of fires in 2 decades. In California, this was even further pronounced. Nearly 4,000 additional people were exposed for the same burned area in 2 decades. In Eastern United States, we are seeing a decline in the number of people exposed to burned area per 1,000 square kilometers. And that's because of several reasons, one of them being that we have huge prescribed fire initiatives in the Eastern United States. Prescribed fire means that when we have conditions that are not extreme, so that the fuels can burn, but they're not dry enough that we will have an erratic fire behavior. In that case, we'll burn that fuel in the times that are mild, and then that fuel is not available for the times that the weather is dry and the drought comes in. So basically what we see, the trend in the East is mainly driven by Florida, and that's mainly driven by about 1 million acres of land being treated annually in Florida. Now, so the fires are becoming more destructive. Per certain burned area, we are seeing more exposures, but that doesn't really explain whether people have gone into areas that burn later, or is it the fire that's encroaching upon existing human settlements? To answer this question, we ran a counterfactual scenario analysis. So we have our dynamic fire parameters, we have our dynamic populations, we have our dynamic exposure to fire that I've already described. In the scenario, we take all the fire parameters, keep them dynamic annually. We fix the population in year 2000. So the population is not changing anymore. It's not moving, so there's no migration, and it's not increasing. Population is fixed in year 2000. And then we calculate the counterfactual exposure. The difference between the two shows basically what is the contribution of population dynamics to increasing exposures. And this is a complex figure. I just get to the point here. Across contiguous U.S., only 1/4 of the increasing trend in population exposure was attributed to population dynamics. So 3/4, at least in the 20 years of our study, from 2000 to 2019, only 1/4 of the trend is attributed to population dynamics. That includes both migration and increasing population. This is basically fires have become really uncontrollable, and they encroach upon human populations, the populations that have been there for decades. Now, I also promised to talk about infrastructure exposure to fire. So we talked about human exposure to fire. Let's quickly talk about infrastructure. What you also have seen across the contiguous U.S. is that the roads and the power transmission lines that have been exposed to wildfires is also seeing an increasing trend. Cumulatively, from 2000 to 2019, we have more than 400,000 kilometers of road being exposed to wildfires, and that has increased by about 60% in 2 decades. Transmission lines, nearly 15,000 kilometers, and that has seen an increase of 70%. And that's very important, because roads are, we use roads to transfer goods. So that basically cascades the impact of fires on different sectors. And also roads are ways to evacuate. In just this past summer, Highway I-84, which connects Washington and Oregon to Idaho and the rest of the United States, was closed several days due to a raging wildfire that we had in Eastern Oregon. So that basically cut the flow of goods for several days across the nation. We also had Highway 21 that connects central Idaho to Boise, where I live, right here. And that Highway 21 was also closed for several weeks because of the wildfire. And now what has happened now is that it's now closed because of avalanche risk. So all the wildfires that happened there clear the vegetation, clear these trees that were anchor points for the snow sheets and the snow that we have in that region. And now that snow can create avalanche. And now that same highway is now closed because of the avalanche risk. So basically what's happening is the impact of fire is not necessarily just within the boundaries. It's not necessarily just during the time of fire, but it can propagate to different sectors. It can propagate to different times and extend the impact. In terms of the power line, and this is the transmission line. This is not even the distribution line, and this is quite dangerous. When the transmission lines fall within the boundaries of fire, they'll have to cut energy because it's a danger for firefighters, and it interferes with the firefighting operations. And a lot of people depend on the electricity that these transmission lines provide to them. For example, there was a 90-some-years-old grandmother in Camp Fire that was trying to evacuate her house, but the power was shut. She could not open the garage door. She was on the phone with her grandson, telling him that, hey, I'm trying to open the garage door. The power is out. I cannot open it. So she could not evacuate. She could not flee the fire, and she unfortunately lost her life. So, the impacts are huge when we have such a great number of, or the great fraction of roads and transmission lines being exposed to wildfires. Now, I want to get back to that human exposure. I want to talk a little more about what the background social vulnerability of the people do in terms of how they experience wildfires. Here, I'm showing two images. One is this gentleman in Eastern Oregon that lives in a mobile home, and the fire is approaching, but this person is trying to fight the fire with a water hose, and it's trying to wet the neighborhood so that when the fire comes, it doesn't burn through the neighborhood and goes around. And that's one way to do it. I would not recommend it. In Southern California, in Los Angeles fires, at least 2-3 people died when they were trying to save their homes. The way it works generally is that if you keep your roof safe and if you do not have vegetation around your house should be fine in a fire. This person is trying to save the roof, obviously, but the vegetation around the house is tricky. So the flames from the vegetation will catch on this fire. In any case, this is a very dangerous situation, but the person decided to stay and fight the fire. And then we have wealthy people in multi-million-dollar houses that live, in this case, in the foothills of Boise, where I am, and they probably have an easier time leaving their houses. They have insurance that they would cover their houses. They have probably other avenues of money coming in that they can rebuild if their house is burned. So the impact, the experience of the person that is in a mobile home and the person that lives in a multi-million-dollar home is very different. So that background social vulnerability matters when it comes to fire experiences. Social vulnerability is the degree of social, economic, and demographic susceptibility to harm from a hazard. This is pre-fire, this is intergenerational and generational. So the fire necessarily doesn't have an impact on social vulnerability, at least pre-fire, right? So the social vulnerability happens pre-fire, and it drives the experiences that people will have with fire. Now, the fire can worsen social vulnerabilities, but basically, in general terms, social vulnerability is pre-fire. And differential access to social, political, and economic resources affects the ability of individuals and communities to mitigate, adapt, and respond to and recover from fire. Let's go back here. Let's talk about mitigation. So this person is living on the verge of all these wildland fuel, all the conifer forests that can burn and have long flames that will impact this. So in terms of mitigation, we are not really doing good here. In terms of mitigation, look at all these houses, all the green space around the house. That's basically buffering the fire from approaching the house. So that's fine. That's the mitigation. In terms of adapt and respond to, we talked about response, right? So this person decided to stay and fight. These people probably have left already. So in terms of response, that's a lot easier when you have the economic resources, when you have a car to leave, and when you have the other measures that enable you to leave early. And in terms of respond to, if this person loses his house, it's probably a lot harder for him to come back and build compared to these people that have insurance and they will get federal assistance and other assistance measures to come back and build. Now, if that has not been enough just yet, let me tell you stories of two individuals who lost their lives in the campfire in California in 2018. Herbert was 80 years old. He had a severely sprained ankle that prevented his mobility at the time of fire. He made several calls asking friends for help, but people were not able to help him because the fire was fast growing and everyone was trying to save their lives. Vincent was 65 years old. He was a partial leg amputee and he didn't have a car to flee the fire. So that background social vulnerability, see the case here, is impacting how people, at least in this case, respond to fire. So what we did in this study, we only focused on 3 states, California, Oregon, Washington. That's 3/4 of all exposures to wildfires across the United States. We took the social vulnerability index from the Centers for Disease Control and Prevention. We overlaid it on fire parameters. We overlaid it on population maps. And we estimated both the exposure to fires and the background vulnerability of the people that were exposed to fires. Now, The social vulnerability index that we have adopted in this study is coming from CDC, the United States Centers for Disaster Control and Prevention. It has a hierarchical order. We have the overall vulnerability. What I will present mostly today is the overall vulnerability, but it has 4 dimensions: socioeconomic status, household composition and disability, minority status and language, and housing type and transportation. And each dimension has several sub-dimensions. Socioeconomic status depends on the income, depends on employment, education, and others. Household composition and disability, age, disability, and others. Minority, obviously, the people who are minority or not, speak English or not, housing type and transportation, mobile homes, crowding, no vehicle, and group quarters like prisons and dorms and other things. Now, I want to talk to you about the geography of wildfires and the social vulnerability. So what happens in our study when we look at California, Oregon, and Washington, the highly vulnerable population. Now, let me step back. The social vulnerability index is between 0 and 1. It's normalized. 0 means the lowest vulnerability level. 1 means the highest vulnerability level. And if we take the highest vulnerability level, so the social vulnerability index more than 0.75, so these are the higher vulnerability populations. High vulnerability populations accounted for only 8% of exposures in California. And that's geography. I will come back to this. And more than 40% of exposures in Oregon and Washington were high vulnerability. Now, in California, if we look at the low vulnerability exposure, so this is basically the more red we see here, it's the higher exposures in the low vulnerability counties. So if we look at the exposures in the low vulnerability, this is all the coastal areas that we have multi-million-dollar mansions, we have wealthy people, and we have a frequent fire regime in these areas. This is shrubland. So that's the frequent fire exposures that we see in these areas that are also low vulnerability. But as we go inland, so if we look at the high vulnerability population exposure, we see that, let's focus on California. We see that we are going inland. So the farther away we get from the coast, we see more and more exposures in the high vulnerability group. And also that happens in north central Washington, which has a high tribal population, also in rural areas of Oregon, and also some suburban areas of Oregon, and also rural areas in central Oregon. Now, what we have observed is from the first decade of our study to the second decade, the largest rate of increase happened for the high vulnerability group. So nearly 250%. That's 3.5-fold increase in the number of people that were exposed to fire and had high social vulnerability. Again, in California, let's look at the percentages of the people in each group, in each social vulnerability group. The high vulnerability group were 5% of all exposures in the first decade. They grew to 11% in the second decade of our study. In Oregon and Washington, it grew from 25% to 47%, and it grew from 37% to 45%. So basically, in Oregon and Washington, nearly half of the population that were exposed to wildfires were high vulnerability. And there were some interesting patterns in the dimensions, which I will skip in the interest of time. We also did a counterfactual scenario analysis to see whether it is fires that are encroaching upon high vulnerability populations, or is it the high vulnerability populations that are moving into areas that burn later? Again, geography matters. In California, socially vulnerable people move to areas that burn later. This is partly because of the housing prices that pushed some populations from dense metropolitan areas into wild and urban areas that observe fires or experience fires. In Oregon, Washington, it's the fires that are encroaching upon socially vulnerable populations. So we have the rural population, we have the tribal population that have a sense of place, or they care for the place they live in, the place matters to them. And these are the population that now, with global warming and uncontrollable fires, the fires are encroaching upon them. What can we do? Basically, I skipped a few slides to make sure we talk about some strategies of what we can do. Let's talk about the fire triangle. So we have, in terms of temporal scales, we have seconds all the way to decades, and we have, in terms of spatial scale, we have square meters to several hundred square kilometers. In low spatial and temporal scales, we have flames. So with flames, we need oxygen. The wind is creating it. We need fuel. So basically all the trees and shrubs and everything that's there, and we need heat. So we have flames. In terms of medium scales, we have fuel, weather, and topography. In terms of larger scales and longer scales, we have vegetation, ignitions, and climate. Now, several of these we can change. Some of them we cannot. Topography we cannot change. Climate is changing, but the less climate change, the less warming we have, the less frequency of uncontrollable fires we will have. So basically, mitigating climate will help with wildfires. But also there is ignitions and vegetation that we can control, and I will talk about that in just a second. Now, there are certain things we can do to protect our houses. One is just Google Firewise. If you live in an area that's fire prone, right, you want to make sure that you follow the guidelines that Firewise provide. For example, 0 to 5 feet. So feet multiplied by 0.3, that becomes meters. Between 0 to 5 feet, you shouldn't really have anything that can burn. So the mulch, the fences that are wooden, etc., remove them all. There should be nothing that can burn within 5 feet from your house. Within 30 feet from your house, the vegetation should be really sparse, and you want to make sure that if the vegetation catches on fire, and if it's not if, when the vegetation catches on fire, the flame doesn't get to your house. And then up to 100 feet, we can have more vegetation. I mean, the density can be a little more, but still, density the density should not be high. We should really have sparse vegetation to provide that safe zone for firefighters to save our houses. That's one. The other things to consider is that the roof and the porch are highly vulnerable to catch on fire. Embers, those sparks that travel really far from the fire, can sit on the roof and start the fire. So you want to make sure that your roof is not asphalt shingle or it's not from a material that's burnable. Also, porch is super important in terms of saving your house. So making sure that the porch is not flammable either. In some forests, especially in the conifer forest of the Western U.S., for which we have seen a lot of increase in density of vegetation, treating the forest is necessary. For example, the untreated forest, dense forest, looks like this. There is a lot of vegetation. That there is a lot of ladder vegetation. So this small vegetation, these small trees can catch on fire and take the flames to these larger trees and become a crown fire. You want to make sure that you remove these small trees. See here, after removal of those ladder fuels, when we have a fire, the fire really doesn't get to the crown, so it doesn't become destructive, and the forest will survive. But when we have this dense forest, these ladder fuels will take the flames to the larger trees, and we'll have crown fires. We'll have really disastrous post-fire situations. And this is not for everywhere. Like in boreal forest, it's hard to do this, but in certain forests that we have seen an increase in vegetation density, this is useful. And then the other thing was ignitions, right? 84% of all fire ignitions across the United States are human started. And there is temporal and spatial patterns to these fires. For example, fires, the red ones show all the human ignitions across the contiguous U.S. You see that July 4th is the highest number of fires that we see across the country. And also there is seasonality, depending on which region you are. So there is a pattern that we can explore to predict and prevent where the fire can happen. there is also spatial patterns. See, the fires are happening where human populations are and also where the roads are. So we can use that to predict when and where the fires might happen. You just need to use some biophysical factors, biophysical, social, and management factors to be able to develop a model to predict when and where that human ignition can happen to prevent it. Now, I told you about this fpa.fod.boisestate.edu. Here you see how you can visualize all the fires, and you can click on each fire and you can get all the biophysical, management, social, and other covariates associated with that fire. So have a look at this portal. This is, in my opinion, this is very useful. It provides a variety of information about historical fires in the U.S., which fire managers are actually using right now to inform their prevention strategies. We are finalizing a model right now that can predict the ignition probability. We are working with Forest Service in the U.S. and other agencies, the Bureau of Land Management, to deliver this model to them. The model is almost ready. But basically what we have done, we have taken all these variables, weather, land cover, social factors, infrastructure, management, and other things. And we have taken fire and no fire samples, and we used machine learning models to predict when and where human ignitions might happen to inform strategies to prevent/reduce. With that, thank you so much for your attention. I want to acknowledge that this work was done by my former PhD student, Arash Modarasirot, who's doing fantastic right now, works for Linker, and also a fantastic collaborator and mentor, Dr. Joanna Badzoglu. And the work was funded by the Joint Fire Science Program and National Science Foundation in the US. Thank you so much. I'm here to answer any questions that you might have.
Thank you so much for a really fabulous talk and a potentially life-saving one as well. I think your slide on slide 30 or 31, where you showed the risk of ignition from roofs and from eaves. I think this is all really, really critical information. And we look forward to looking at your machine learning model as well when that's available. To start off, I wonder if you could talk a little bit about how the exposure of socially vulnerable populations to wildfire in the West Coast of the United States might compare to the exposure of socially vulnerable populations in other countries. We've been seeing on the news, both here in Canada and Australia, Portugal, Brazil. Have you looked into that, and what kind of lessons might you be able to share on that?
Absolutely. Thanks for that question. We actually have a paper that's on that very specific topic that's under review right now. It's the global patterns of fires are quite fascinating. So 85% of all exposures to fires happen in Africa, which is obviously the vulnerability is higher in certain sense, in certain areas, including economic development and other things. Now, what happens in Africa is that we also have a lot of low intensity frequent fires. So the fires are not necessarily all bad. The fires that are bad are those intense, huge fires, huge in terms of flames, not in terms of area burn. We have burned areas in Africa that burn through millions of acres. These are low intensity grass fires and doesn't really have much impact on the population. So 85% of all exposures happen in Africa, but a lot of it is within low intensity fires. Now, we also have high intensity fires that happen in Africa again. It's a smaller population compared to all fires, but still notable. And there are regions, and we are looking into it right now, there are regions like in South Sudan that we have a lot of these intense fires. And these are some of them are fires that are used in war. And I mean, I don't really have a solid story to tell you right now because this is evolving. But it's quite fascinating how fires are even being used as a war measure and really impacts population in that way too. I'm just going to stop here to make sure that we have time for other questions.
Thank you. Yeah, and remind our audience to please put your questions in the Q&A box. We have one question that's come in. Wani Lin says, thank you for the presentation. Do you think this method is applicable in other regions in the world, Mediterranean, Middle East? And I guess maybe if you could expand a little bit on the machine learning model that you're developing as well.
Absolutely. In terms of the exposure piece, we have a paper that's looking into global fire exposures. That's under review right now. What really took a lot of time from us was to figure out where actual wildfires happened, right? So we have noise in all global data. And that noise is really impactful when it comes to population. When it comes to burned area, that noise, that small pixels of false alarm. So this the pixels that were not really actually wildfires, but we are getting a signal from the satellites that these might be wildfires, and those are in the global data. In terms of burned area, those noise pixels wouldn't really make much of a difference. But in terms of exposure to wildfires, they do. So because a lot of them happen in areas of high heat that are urban areas. So when we look at the population exposure to those noise pixels, the population exposure is high. It's urban areas that are providing or creating that noise signal that is captured by wildfires. So what I'm trying to say is, as you are applying this work to other regions, be very careful about whether this is a signal or a noise. So that depends on whether we have good burned area products regionally or not. In the US, we have a really good historical data set of wildfires. We have, we have separated prescribed fires from wildfires. We have really honed in and we made sure that the boundaries are correct and everything. So that it works perfectly in the US. In Canada, there is a good data set that came out, I think, last year. In certain areas, Portugal, Spain, Mediterranean Europe, there are good data sets. But as we get to Asia, as we get to Africa, the data sets become a little tricky. So we want to make sure that as we use the global products, we are careful about noise in the global products. Please repeat your question about the machine learning part. Sorry, I forgot that.
If that's part of your plan to expand it to other areas.
Absolutely. Well, the machine learning part has shown also really interesting results, and it also has been challenging in terms of making sure that we have a model that's generalized. In the US, we have a really good data set of human ignitions of wildfire. So we have a data set 2.3 million. So that fpafod.boisestate.edu, that you can visualize 2.3 million fire incidents between 1992 and 2020. So we know where the fire happened, we know when the fire happened, and we have attached more than 300 attributes. What was the land cover? What was the weather? What was the distance to road? Other variables that are connected to the mechanism that drives or contributes to ignition of wildfires. That data set, to the best of my knowledge, is not available for the majority of the world. There are data sets in terms of ignition in Mediterranean areas, but how granular they are in terms of daily, in terms of where they happen, I don't really have a good information on that. But when we get out of Mediterranean Europe, Australia, Canada, and the US, data becomes rare.
Thank you. We have another question, but it's come from in the room. Dr. Rohit Ramchandani, maybe I'll let you.
Sure. Thank you for a fantastic presentation, Murji. I was just, you've actually already probably touched on the second part of this question, so I'll just focus on the first. Right now, a lot of people thinking about Canada, U.S. relations, etc. And, I know a lot of fire resources and capacity were sent down from Canada to help with the California fires. I was actually just wondering about, in terms of cost-benefit analysis of prevention versus response, and of course, thinking about response as an asset that Canada can offer and to the States. Do you know of any analysis on kind of cost benefit comparing the two?
There are certain analysis that came out. I haven't worked on them, but a great colleague, Dr. Jeff Presteman, from Forest Service, has looked into the cost benefit analysis of prevention. Obviously, the cost benefit analysis for prevention is there. The prevention is really economical. The problem that happens is that majority of the U.S. Forest Service budget is used for fire response. And when it comes to emergency, it's a lot easier to spend those resources. Prevention, you're preventing something that may or may not happen. And if that doesn't happen, they come back and say, see, that didn't happen. You used that money for nothing, right? So it's very unfortunate, but that's the reality of human behavior, and that's the reality of some of the propaganda that goes around and impacts a lot of the decisions. When it comes to resource sharing, obviously, I am in Boise, Idaho, and the National Interagency Fire Center that basically coordinates all the resource sharing globally is right here in Idaho. And right now, everyone is confused. No one really knows how things will evolve, right? We have had resource sharing with Canada. We have had resource sharing with Mexico. A lot of the Mexican firefighters have came into help for the United States. And also, what really is important to consider is that the seasonality of fires in Canada, the seasonality of fires in certain regions of US and Mexico are very different, right? So it's very important for us to be able to send these resources around, because we don't need to have hundreds of thousands of firefighters sit around for the fire to happen, right? We have firefighters in different countries with different fire seasonalities that can fight fire in this country in this time and move to the next when the fires peak in the other country. So it's super important. I still hope that years of collaboration between agencies will continue on. The only thing that we can do at this point is just to stay hopeful.
The UN firefighting squad, we need it.
But we can also now send you 25% more help because of
we'll pay for it. This is the consumers that will pay for that. Yes.
Thank you.
Absolutely.
we have time.
Yeah.
But there's one more. Yes.
We have a couple of questions. I'll try to get through them. Thank you very much for your wonderful presentation. So Sanjeev Bhutta, I have a question regarding data collection for developing the machine learning model. Given that there are many burnable and non-burnable elements around a house, how did you gather data for different components, such as windows, doors, and roof materials, as well as outdoor elements such as vegetation and furniture? Did you rely on existing data sets, manual annotations, or any specific data acquisition techniques? And if I can add on to that, we also have a question here from Professor Chung Cheong, who's asking about materials and why there seems to be how to handle the behavioral aspect of people rebuilding with burnable materials.
Well, in terms of the first question, we do not have a good large-scale data set of the materials of the houses. We have smaller scale LiDAR data that just shows where vegetations are around houses, not the materials of the house. We might have smaller scale data sets in cities and counties, but that doesn't exist even in the US at the large scale. There are LiDAR data that shows where the houses are and how the flames from one house can impact the other house. And I want to make sure here that we separate the urban fires from wildfires, right? So we have models that can develop, can predict the propagation of wildfires in the wildland, and the propagation of wildfires in the urban areas are very different than the wildland. Now, there are data sets, LiDAR, that shows you where trees are, where burnable vegetation that can be detected by LiDAR, not necessarily the material of the house, but where the trees are, where the shrubs are, and other things. So that's available. But I'm not aware of any data set that shows what materials are used in each house. In terms of the second question, there are building codes now in place in California, not elsewhere. Oregon is starting to adopt some, Washington is starting to adopt some, Colorado is starting to adopt some. We are behind on developing those building codes that are necessary to ensure our communities remain safe. I don't know if you saw that picture in the in Los Angeles fires. There was this one building that wasn't burned, and it was this is a miracle. This building was within the fire and it didn't burn. No, well, that was the miracle of concrete. Concrete does not burn, right? So it's a matter of it's again, it comes back to the cost benefit analysis. It comes back to is it wise for us to just build all houses with concrete? Probably not. It's not economical. Is it wise for us to change our roofs? I would say yes. In wildfire prone areas, we should go ahead and change all those roofs that are out. They will catch on fire. And the problem with these urban fires is that one catches on fire and then the flames are so long you cannot really fight it anymore. So if you can prevent that first one, then you can prevent a community. But when that first one starts, it becomes really hard to fight it.
I think we'll have to invite you back for another conversation about all this. I think these are all really important points, and I'll pass the floor to our director.
Is there any question from the audience? Additional question? Okay. No, so I think we are over time, so I'm not just one last question, and thank you for the wonderful work you're doing, and then also the presentation today, Moji. Is the impact of climate change on fire exaggerated, you think, in comparison to the other contributors to fires?
Absolutely, and this is a fantastic question. This is very regional, right? When it comes to boreal forest, absolutely, right? When it comes to fires in California, like those shrubland fires, did climate change contribute? Sure. Was it the only factor? Probably not, right? So it's very regional when it comes to forest, when it comes to areas that we have wet fuel. Climate change absolutely contributed, the main driver. When it comes to areas that we have had frequent historical fires, did climate change have an impact? Sure. Is it the main? I can't say. Especially in California, what happens is it's not just the warming, it's the hydroclimate whiplash. We go from these wet years into dry years, and then we go from dry years into wet years. So that cycle contributed to more frequent and not more frequent, but more disastrous fires.
So why do you think, like, I mean, when the fire was happening, the media was talking about climate change. Why do you think this happens? Like, despite the fact we have so many good scientists like you, so immediately people attribute the event to climate change or mismanagement. I mean, the other way around. We also have the new administration doing all the blame game. In a different way. So like, these narratives very confusing to the Americans, I would say, and the whole world.
We have a paper that's coming out that we ask a couple of questions. I don't have a good answer for your question, Let me start with that. But the paper starts with a couple of questions. Is it climate change? Maybe. Is it mismanagement? Sure. Is it water hydrants or fire hydrants? Sure. But I mean, let's talk about this narrative around Los Angeles fires, because that's fascinating in my opinion, right? So can you tell me that without climate change, we would have the same fire? I would say yes. We could have had the same fire in California, in that region, without climate change. That is the regime of fire in that region, right? Is it mismanagement? Sure. The mismanagement is that we want to live in an area with aesthetic beauty, and we built in an area that burns. That's the way it works. So what do you expect? You jumped in the ocean without knowing how to swim, and you'll get drowned. That's the way it works, right? Could we have prevented those fires? Maybe, right? But I mean, we have 25 million people that live in that region. It takes one mistake to start that fire. So when we have more and more frequent number of days that are conducive to that erratic fire behavior, one of those people is going to make a mistake. One of those people is going to start a fire that will become disastrous. That's just how it works, right? Is it a water problem? Absolutely not. I mean, how we don't have the infrastructure to transfer all that water to fire hydrants. And when 16,000 structures are burning, or several thousand structures are burning simultaneously, how many fire hydrants can you have? Will you send a firefighter to fight the flames that are 10, 20, 30 feet long? Is it possible to fight that fire? Absolutely not. You can't do anything when it comes to that point. So it's, disasters are always weaponized in different ways. That's my answer. I don't have a better answer to give you.
Yeah, no, but I think that's the point. I think that, and this, weaponized by different groups, and sometimes weaponized by scientists who forever have been, have dedicated their career to climate change or water, and everyone is looking for an evidence for their stories, right? So journalists and so on. So when a disaster comes, that's an opportunity for getting attention, and that's an opportunity to promote a narrative. Sometimes we like those narratives and sometimes we don't. And I think that's when, we have responsibility to be factual and remind people that the blame game is not going to help the victims, first of all, and then it would not lead to proper action also. So thanks for writing that paper. We're looking forward to reading it. And once again, thank you so much for the wonderful talk. And yes, we hope we can have another really long conversation on this topic later on. Thank you.
Thank you.
Absolutely. Thank you all so much for attending.